All right, good morning, everyone. How are you guys doing today? Good. Happy Friday. I'm super excited to see all of you here with us today. My name is Brittany, and I'm representing our Intuitive Planetarium here at the U.S. Space and Rocket Center. And again, I'm super happy all of you are joining us for today's session. I have the honor of welcoming today Nathan Klose to talk about the AI-XR connection, virtual reality, augmented reality as the interface for AI. And to introduce our guest speaker today, Nathan is a creative director who cares. His award-winning work has touched multiple well-known brands like Disney, ESPN, Adult Swim, Marvel, Mercedes-Benz, and many more that you've probably heard of. With over a decade's experience in his field, from interactive game-based education, XR experiences, to computational linguistics and user experience design, even business strategy and marketing across industry and commerce, he is trying to show that at every effort he cares about where we have come from and where we are going, and how we can offer that to one another. And emerging technologies such as AI and XR are an avenue for this. And during today's session, Nathan hopes that you also will care, alongside him and everyone else here at this conference, about what is next in AI and how we can intuitively, practically, and persistently interface with it. So if all of you would please join me in giving a warm welcome to Nathan Klose.
Well, hi there. My name's Nathan Klose. I am the Senior Creative Director over at a company called i3. i3 does a bunch of different things, including cyber, cloud, virtual training, traditional engineering, digital engineering, and a lot of what I've come across at my company and in the last year, going to conferences, going to events, speaking at them, paying attention to what's going on in the world and online. There are a lot of things that are starting to kind of poke up with regards to how AI is a great platform candidate for a platform called XR. So whenever I say XR, that's just think of the X as a variable. It just stands for a V or an A. V is in virtual reality, so you've got a headset on and you can't see through it. It projects exactly what's going on in your head. That's like your MetaQuest Pro, right? And augmented reality, that's like a Magic Leap, or if you've ever used a Snapchat filter, right? Where it uses your camera and overlays things. So let's get into it. No one has any idea what's happening. No one does. You will watch videos online, you will hop on LinkedIn, you will hop on X and Discord, and you name it, and everyone's going, yeah, VR, it's a thing. And everyone's excited about it, but no one has any clue what's going on. They don't. There are a lot of futurists out there who are like, okay, XR, here's what we can do with it, right? They don't know. No one knows. It's all experimental. It is a very vast blue ocean, and we're just popping a couple boats in. So keep that in mind. If you come across something similar, it's speculative at best. But I'm going to talk about some of where the rubber hits the road events that we can get through. So that dude right there, that's all of us right now. We have no clue, zero idea what's happening. And if you were to go online and look up, buzzwords for what's happening, for all this emerging technology, you'll come across a lot of them, right? Digital twins. Raise your hand if you've heard what a digital twin is, or you've heard that term, right? Okay, yeah. What about metaverse? You heard metaverse? Okay, right on. Spatial computing, edge computing, anybody? What else? What else? AI, just multiple, just keeps going. It keeps going, but it's all a load of crud. Because this is what we're talking about today, right? There are a lot of buzzwords, a lot of things that we are trying to connect the dots on. And I would say if you go research any of these topics, you're gonna be good at collecting the dots, but not connecting them because no one's there yet. So just kind of don't pay attention to any of that stuff. I promise I won't use too many buzzwords. I'll try to explain it plainly to everybody. But the goal right now is to chat about this. I may throw a buzzword in there once or twice. All right, so let's talk about AI and XR and all of the work that's going into it that's pragmatic and practical right now. As of 2019, there have been over 300 academic papers. These are people writing at universities. These are people who are researchers, right? 300 academic papers that are specifically around the connection, the bridge between AI and XR. There's a lot of research going into this. Augmented reality in particular, so that's that Snapchat filter, right, or a Magic Leap or anything you've ever seen. Has anybody ever tried on a Magic Leap before, or a headset that has pass-through? Okay, y'all know a little bit what I'm talking about. Augmented reality in particular benefits greatly from AI. And that's kind of baked into the hardware itself, right? And let's talk a little bit about the hardware. So the hardware for AI and XR exists on the same chip now. In your phones, for example. Raise your hand if you're an Android person. Raise your hand if you're an iPhone person. Both of those chips, the M1, the M2, the tensors, right, in your Google Pixels, the Snapdragon CPUs, those are all already being built out to handle AI models and visualization in XR. So great example of this is when Apple announced their R1 chip, so the Apple Vision Pro, right, everybody's seen that in the news. That absolutely threw Qualcomm, who makes the Snapdragon chipset, it's typically in a lot of your Android phones, threw them for a tailspin. They're like, oh, heck no, we ain't gonna, so like they pushed out their XR Plus 2 chip, generation 2, out to the masses like almost immediately after Apple announced that they rolled their own silicone for this. The industry is working heavily to do things with AI and XR on the same chip. That is where the technology and hardware is going. So that's a thing to consider. That's gonna give us context on what our phones are gonna be able to do. One of the cool things that I saw out at a VRARA, or Virtual Reality Augmented Reality Association event. So there are a couple different events out there that you go to for this. There's the VRARA, or VRARA. And then there is something called AWE, which is Augmented World Expo. They are competing conferences. They have varying degrees of membership and involvement. Both of those conferences, the Snapdragon folks came out from Qualcomm and said, let me show you something. And they pulled out a phone device that is intended to directly pair with an augmented reality headset over Bluetooth. And they said in the future, you might not even have a screen. You just might have a compute device hanging out in your pocket, slowly cooking your thigh because it's so hot. But that's gonna be computing localized AI models that will help you perform tasks, right? It's gonna perform calculations with the data that's coming in from your glasses headset, right? Whatever this is. I mean, these are deliberately clunky, this is like deliberately clunky eyewear, but it's not AI, it's not XR, but you can look at it and kind of think they'd be kind of chunky boys, right? Everyone's gonna look like they're like cool and emo from like the early 90s. And the idea that they put out with their newest Snapdragon XR2 Plus Generation 2 chipset was, those models are running using these sensors to make sense of the world around us, and they are also running to visualize and overlay things for you, same time. That is where the tech is going. So the hardware's there, right? And a lot of people are not really, they don't have access to this hardware, and they're not really sure how they can make it work. But if you go to LinkedIn, look at me, I'm wearing the monkey suit, I'm on LinkedIn all the time, you guys can just guess, right? There's a lot of cool tech demos. Cool tech demo, bro. It's mostly what comes across, right? There are so many cool tech demos because the hardware's not here, it's almost here. But people don't care. They're so excited about the premise of this, they're already making stuff. So I want to talk about not only things that are happening at conferences, but things that we are seeing online right now. So I'm going to give you a little bit of it around the world, right? How is AI used for content creation in XR, right? How do users interact with AI in XR right now? And how is XR, because of those two, going to be a true upcoming interface for AI? These are the three things I'm going to cover around the world, right? Let's talk about the first one, and this is super cool. So where I work, and for many years, I worked in a portfolio in our company called TADS. It stands for Training Aids, Devices, Simulators, and Simulations. And if you're in Huntsville, you know, it's just acronym soup all day long, right? That ultimately got me heavily involved in game engines. So if I say the Unreal gaming engine, does anybody, raise your hand if you've heard of Unreal? Raise your hand if you've heard of Unity. Okay, right on. So I work in game engines all the time. And one of the things that I am super excited about is democratizing people's ability to put content into game engines to quickly output information that would go on a headset, go on a display, you name it, right? So let's talk a little bit about that and how challenging it is to get 3D made. So you've played a video game, you've used a Snapchat filter. 3D is in fact extremely challenging and complex. It's chuggy jam to get through. So when it comes to 3D modeling, there's a lot to know, and it's not easy to know. Okay, here's a weird one. When I say implicit knowledge and tacit knowledge, gently raise your hand if you think you might know what that means. All right, I'll give you a rundown. Implicit knowledge is stuff that you can educate on. It can be explicitly exchanged from one person to another, and you can learn by watching, doing, things like that. But it's not quite the same as tacit knowledge. That stuff's hard to understand. That's like you've been doing something for 10 years, the way you do it is yours. You cannot explain it to someone. The workflow, the pipeline, everything that you do well, right, that's yours and yours alone. When it comes to 3D modeling, some of the best 3D modelers are trying to shove implicit knowledge inside of their tacit knowledge. And if you're a 3D artist, this is literally what it looks like. Chunky socks. Walk around in that for a little bit, right? You got UVs wrapped and unwrapped. You got lighting, rigging, topology, texturing, LODs or levels of detail, hard edge versus non-destructive, right? Shaders. There's a lot that goes into this. And then the way after you learn how to do that to make it good is all on you as an artist. It's a lot to keep up with. I'm just gonna go ahead and tell you that content creation-wise, it's getting better. And we're putting tools in the hands of non-3D people to make 3D stuff. How non-3D stuff becomes 3D stuff. That's literally what all this stuff does, right? So here's some cool stuff. Take a photo of this if you're interested in it. NVIDIA, graphics card company, they're more around AI now. They have a product suite called the Omniverse. It's just a bunch of other people's computers that you connect with and do cool things with. One of those projects up there that they have is called Get 3D. Get 3D, that's all it is, it's super simple. What does that do? It is a generative AI tool that allows you the chance to input something 2D and it will make it 3D for you, right? And it's also a tool where they can kind of demo the things that they've made from 2D to 3D. So Get 3D is one thing like that. Imagine being able to feed something a photo or two and then get a game-ready 3D asset. Game-ready, meaning that can go into Unreal, that can go into Unity quickly so that you can then throw it on an XR headset of some kind, right? Luma AI and 3DFi.ai. These are cool. All right, stupid question. Raise your hand if you've used ChatGPT coming to the AI Symposium conference. You have used ChatGPT and you've used ChatGPT to use DALL-E. Now raise your hand. Have you used DALL-E or Midjourney or any of these tools that allow you to type a prompt in and it outputs an image or a video? Has anybody recently seen OpenAI's release of Sora? Okay, so there's a funny video that floats around right now, or more recently, referencing a video from many, many years ago of Will Smith eating spaghetti. Have y'all seen this? Okay. So it's a video where someone used one of these tools early on to say, I want a video of Will Smith eating spaghetti. And it's a mess. It's bad. It's bad. So Will Smith recently, after Sora announced what they did, he actually filmed a video of himself eating spaghetti. And then, they were like, man, AI is getting so good. It's totally him. It's him eating spaghetti. So if you've used those tools to generate an image before or a video before, Luma AI and 3DFi are text to 3D generators that will also generate game-ready assets to go into Unity, to go in Unreal, to go into Godot, all these game engines, right? These real-time 3D engines that all you have to do is say, I want a dresser. Well, I want the dresser to be painted off-white and I want it to have a lot of ornate detail. Well, actually, I want everything to be brass, but I want it to be weathered brass, right? And you can describe this and it will output iteratively the thing you're looking for. You can download it, you can put it in your game engine, and suddenly with an XR headset, there's your dresser, right? You can even say, I want to model some clothes that go into it, right? You can model the clothes that go into it. I want them folded like they're folded at Target, not like they're folded at Walmart. You know, you can go super deep into this and create assets with these tools, democratizing 3D for non-3D people. And then let's talk a little bit about something called splats and nerfs, similar to surf and turf. No, it's not. Rhymes though. Splats and nerfs, Gaussian splats. That's kind of a technical term, right? Told you I'd try to avoid some jargon, but I can't at this point. Gaussian splats, nerfs. Nerfs stand for neural radiance field. Neural radiance field. Splats and nerfs are getting a lot of attention, but very few examples of how you use that in a headset. I wanted to talk a little bit about that right now. So let's look at this little video. This is a video of a neural radiance field. Now, that's a video of a Gaussian splat. They look pretty similar, don't they? Right? You can't really tell too many differences, but watch for a moment. You see these blurry spots right here? I'll talk about that in a second with the Gaussian splat. That's the splat part, right? You can kind of see, you know, some of the detail is there, some of it's not, right? Oh, that didn't look right. I'm going to show a nerf again as well, right? Okay, cool, pretty similar, you know, not quite the same aberrations. This one right here, this nerf, takes forever to make. Lots and lots of cycles on a GPU to get at this. This also is not quite as useful for XR as a Gaussian splat is. So splats and nerfs are used in a lot of cool demo applications, but this is the first one I've ever come across that someone has used a Gaussian splat in an XR headset. So this is someone picking up their headset, they're putting it on, they're looking around, they're looking up close at details, right? They're calculating the milliseconds of response time, the frame rate or hertz on their headset. You want to have a high, right, like hertz on your eyes because otherwise you'll puke, and nobody likes pukey. And he's just walking around looking at this. I'm going to tell you about neural radiance fields and splats in just a moment and what that actually means. This is one of the few demos I've ever seen of this. And splats are extremely performative, which means they run really, really well on these XR headsets. Let's talk about what a splat is, a Gaussian splat is, and what a nerf is. All right, so imagine, and a lot of people have your phones out, you're walking around and you capture some video. Video. You can get a video of this, kind of walk over here. Okay, cool, I got these chairs and these people. All right, sweet. Maybe I'll walk back there and, you know, kind of get some video of the coffee and the people in the back, you know. You can take that video, as shaky cam as it is, and you can import that into either a nerf or a splat approach, and it will derive out of that 3D data, right? So raise your hand if you know what photogrammetry is. Have you heard that term? Oh, all right, right on. So neural radiance fields are kind of the next level to photogrammetry, right? Photogrammetry is extremely process intensive. I'll talk about what photogrammetry is. So I was talking about getting a video and getting, you know, 3D content from that, which is really, really cool and really, really weird, really, really spooky. All photogrammetry is taking a ton of photos of a thing and then feeding those photos into a piece of software, and the software goes, all right, you've taken photos from every single angle. I'm gonna look at the lighting, I'm gonna look at the angles, I'm gonna like basically process all this for like hours to give you a head start on a 3D object, right? A lot of our 3D artists who work in these game engines, they go and, for example, let's just say a Black Hawk helicopter, right? They go to a Black Hawk helicopter and they spend hours taking thousands and thousands of photographs, high resolution photographs. And then they take those photographs and they go back to a dedicated machine. It's a Beefy Boy machine, it's got a lot of cool stuff in it. And they say, hey, Beefy Boy machine, with the software that does the thing, do the thing. And then 24 hours, 48 hours later, you know, like days and days of processing outputs just the starting point for them, you know? And so then they're gonna model on top of the 3D output for that. Now, I'm kind of exaggerating on the time it takes, but it really depends on how much you're trying to process. What a neural radiance field is a more traditional take on that, but it outputs something that is far more true to life. It uses, okay, I'll try and describe this simply. It uses a neural network. So we've heard that kind of as an AI term before, right? It uses a neural network as a constant function. It is constantly doing a thing to derive lighting and spatial and volumetric conditions of the thing that you have fed it, the video you have fed it, right? So if that video changes or you need to like put it on a headset, it's not gonna run on traditional hardware. It's gonna use a bunch of GPUs or a single GPU to say, all right, you fed me this video, I'm gonna continuously be showing you what I think the volumetric aspects of this thing is. So that video that I showed you earlier of Gaussian splats are very, very different. So what a Gaussian splat is, it's a more rasterized approach. Raise your hand if you've heard the word rasterized before, right? So a rasterized approach should just calculate and reconstruct and recalculate and reconstruct 3D from typically videos now using a bunch of like projection points, right? So all those fuzzy things that you saw, that's projection points, or what they call splats, right? So you're just basically kind of splattering on volumetric data in a Gaussian splat, and it is attempting to recreate a 3D spatial environment, but what it does is it just makes the thing, it just splats it everywhere, and because it's already created a static volumetric asset, you can throw that in a game engine. You can't throw a neural radiance field in a game engine. You can throw a Gaussian splat in a game engine, and that's what like this video was. This is someone saying, well, gosh, if this is a new technology to kind of capture our world and put it on a headset, why can't I put it on a headset now, right? Like if that's the intent, right, to be able to kind of like make a true to life visualization, a visual representation of what's out there, throw it on a headset. And they did. And everyone went, how did you do, what? Right? And people started to build plugins for Unity and Unreal to do this more efficiently and more effectively, right? And this is maybe a few weeks old, if that. Found on Twitter, found on X. Let's talk about the plugins galore that they are doing, right? So the moment someone does an experiment, they're like, yeah, this is really cool. And everyone goes, cool, I'll go to your GitHub. I'll check out what you got. And then they download it, and everyone who is a developer or an engineer by trade, they're like, yeah, I get it. I feel it, feeling it, yeah. Have you tried this? I'm gonna add an issue. I'm gonna add 5 issues, and they're in the throes of it, right? Your common person who is like, how do I just wanna put it on a headset. They're not gonna go to the GitHub and check out the issues and see what challenges there are and deploy it in a Docker container and blah, 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 blah. They're not. So, these plugins are being generated for your typical users who are comfortable in a piece of software like a game engine to import that asset and do it. Imagine that video that you just saw back there, someone went out in their backyard and captured it, right? Imagine they input the video into the game engine says, cool, and then it puts it on the headset. And now, with a Gaussian splat, they have a spatial memory of the thing they just went to, right? Now, I'm not gonna claim to be a futurist. I'm not a big fan of futurists. I kind of live in the here and now on the practical, right? So people who kind of premise things kind of irk me a little bit because I want to see stuff happen in real time. Imagine having a spatial memory of a birthday party of a loved one who has passed away. Imagine capturing video or photos that the common person can upload to a software suite, an online thing, and it outputs an executable for a headset. And immediately, not just a photograph or a video is available to you, but the ability to remember how close your face was to your grandmother before she blew the candles out, right? To remember what it was like when you had your first child, right? Someone's capturing that footage, and you can go, oh, I just want to walk into that hospital room again, where my friends and family were, right? I'm there with it. Maybe you don't. This dude's laughing here. Maybe you don't want to walk in the hospital room again. Maybe you're like, oh no, that trauma is gone. That's in the back annals in my brain. I'm not going to relive it. But there are applications that are being developed here and now for folks to begin to start to do that. And I think that is an absolutely beautiful thing. And the fact that they can run immediate, it takes 10 minutes to make a Gaussian splat. 30 minutes to make a Gaussian splat. Neuroradiance fields, hours. Photogrammetry, days, right? See how quickly we're getting to the efficiencies gained in this technology? And do you see how they're targeting things that are visual like a headset? We're starting to see intersections between emerging technologies like this. And I'm gonna get a little bit further into how that works in XR. So XR, right? Let's talk about interacting with AI in XR a little bit. So I talked about content creation using AI to get it into a headset. Let's talk about what it means to actually do things with it. All right, I promised, but I am not good at keeping promises in presentations, just go ahead and know that. Metahumans, buzzword, raise your hand if you have heard about this, a metahuman, right? Okay, a metahuman is a 3D representation of a human or humanoid character, right? Sometimes it's cutesy, like a Pixar character. Sometimes it's, more representative of a human being, right? And the idea behind this is, you have services on the back end that are running that allow you to interact with that human being or character as though they were there, right? Maybe their job is to chat with you. Maybe their job is to perform a function. You can ask them things, right? You can train them up on content. Let's talk a little bit about this. This is the NVIDIA ACE, or Avatar Cloud Engine. There are a lot of startups that are using ACE right now to generate metahumans. Now, when this demo first came out, the ramen shop owner here that you're gonna see, his voice wasn't super great. Sounded pretty bland. Not a lot of tone, not a lot of excitement. And the person demoing it did not sound like they were excited to be demoing it either. Hey, can you tell me about your ramen shop and what happened? Can you tell me, I heard bad things happen. You tell me what I need to know? And then the AI was like, yeah, my ramen shop really got caught in the crossfire of a gang. It's just like, it was really bad. It was really bad. Give it a couple months in this field, right? And you will see improvements. So NVIDIA went, oh, we flubbed that up. Oh God. They left the original video online, but it's not exactly easy to find anymore. I think I find copies of it, right? And they replaced it with this one. This is months after the fact. This is an Avatar Cloud Engine that's using all NVIDIA products to have a conversation with you. So we'll watch this real quick.
Today we're going to be having a conversation with Jin, a ramen shop owner who has seen some hard times with his ramen business. Using a SteerLM-aligned Nemo large language model, we can influence how Jin responds to a particular prompt at different time. Most large language models today are trained to provide only the good responses. With SteerLM, however, the models are trained to provide responses aligned with particular attributes, ranging from humor to creativity to toxicity. Let me show you. Hi Jin, how's your ramen business going?
It's slow these days.
Why do you think that is? Is your ramen any good?
I think it is. I don't know why it's slow.
Not the most insightful answer. Let's increase his
That's what he originally
helpfulness
sounded
and
like.
add a little bit of creativity to see if his response changes. Now what we're gonna do is we're gonna roll back the conversation and ask Jin the exact same questions again. Why do you think that is? Is your ramen any good?
I think the new flavor I added might be causing the issue. I'm not sure. I've made it more spicy by adding some fresh Korean peppers. That might be the issue.
Could be, could be. Let's increase his humor and reduce his helpfulness. Why do you
That's
think
me
that
every
is?
day.
Is your ramen any good?
I don't know. I can't tell these days. Business is so slow, I'm practically going bankrupt. Thank God I already married.
Okay, now let's make Jin a little offended by our question. Let's increase the toxicity and add a wee bit of helpfulness here. Why do you think that is? Is your ramen any good?
Are you questioning my cooking skills? The only reason my shop is even open is because of my ramen.
As we can see, Jin's responses vary widely with each attribute. With Nemo SteerLM, attributes can be added or removed with further fine-tuning and training. With this new technique, developers can create a model that enables fully customizable responses at inference time.
So the very first part of the video, that's what it sounded like originally. Did you notice the tonal changes, the response, context that he changed up, right? I mean, it was night and day, right? Now, again, it still sounds a little bit, like we got that kind of like sonic, uncanny valley, if you will, right? We're like, that doesn't sound like somebody I know. I don't want to know that person either, right? But we're getting there. And there are services, so that's just their cloud services. There are services that do voices so much better. I'm going to show you a little bit of an example in another one too. All right, so OpenAI. Hey, we've talked about that a lot this week. OpenAI has a number of services called Whisper, something called ChatGPT you might have used. And then there's another service that does voices so much better called 11 Labs. And 11 Labs is a direct competitor with some of the services that OpenAI is working toward. Everybody's trying to get voices down. And we use voices where I work, right? We actually generate training content for people, and they can talk the way that you would expect it to hear. So we found some of the better services, but yeah, we're gonna watch this. So this is a video, and I can't believe that the internet has slept on this. This is a gentleman in the Philippines who has created a video where he has put someone who is a Buddhist monk with a Catholic priest from the 1600s. And he's asking them questions about the meaning of life. He's asking them questions about what is happiness, right? And he asks them independent questions, and then he says, hey, can y'all talk about this? And so they talk about it together, right? So I kind of clicked it up just a bit, and you'll notice, and he has a little text bit in here where he says, hey, the delay that you're about to see is because it had to go across the internet, had to go to space, had to go through the tubes and then return back, reunite with my computer. And so he's clipped it up a little bit, but just imagine when that's not running on someone else's computer, it's running on a localized device in your pocket, slowly cooking your thigh. This is an XR2.
Hello there. Who are you, sir?
Peace be with you, my friend. I am an old Christian monk who has spent most of his life seeking spiritual enlightenment through my faith. I have found that living a simple and contemplative life has brought me much joy and contentment. How may I assist you today?
I want to talk with both of you about how to achieve happiness. What do you think?
Achieving happiness is a wonderful goal, and I think we can definitely share our perspectives on this topic. In my experience, happiness comes from within and is not dependent on external factors. By cultivating a mind of gratitude, compassion, and contentment, we can find joy in every moment, even in challenging situations. What are your thoughts on this, my friend?
I find it difficult to be happy in these troubled times. Do you have any more tips about how to be calm when there's so much stuff going on?
I understand how you feel, my friend. In times of turmoil, it can be challenging to maintain a sense of inner peace. One thing that has helped me is to turn to prayer and contemplation during these difficult times.
He goes on to ask them to talk about happiness together. What does happiness mean for you? What does it mean for you, right? And again, there's a little bit of that sonic uncanny valley. The 3D wasn't super great, so there's a true kind of visual uncanny valley. By the way, when I say uncanny valley, do we kind of know what that means? It's looking at the representation of a human being, either painted or, since time immemorial, some representation, and going, that doesn't look right. The dips and valleys in their face, they don't align with the way I would anticipate a human being, like just a little off, something's a little off, right? It's uncanny. So sonically, the uncanny valley is also listening to these AIs try and generate voice, right? This is another example of how we are using AI in a way that we can experience in XR, not just create content with it. All right. This dude right here, right? So where I work at I3, right, we have a product that we are working on called Helpful Henry, Who is Henry, you ask? Great, I'm glad you asked, it's a great question. Henry is one of our subject matter experts on the UH-60 Blackhawk. And he is a beloved SME, or subject matter expert SME, in our office. Been working there for years and years and years. He owns goats. He lives on farmland. He keeps to himself. He's got this nice accent that just kind of, you know, I don't know. I'm here, you know, like, and he's also extremely knowledgeable in the UH-60 Blackhawk platform. So what we've been working toward, especially inspired by a lot of those things, and again, these are demos, right? And I'm about the practical, I'm about the, you know, rubber hits the road, right? Is a very similar premise where we have a 3D avatar of Henry who's out there in the hangar with you with the Blackhawk helicopter going like, all right, this thing right here, that's called the boom, you know, and it does, right? And he is describing things for you. You can ask him questions. He's kind of like a stand-in for an instructor, a maintenance instructor. Henry has been doing voiceovers for us. We sent him a nice little recording device, and we're like, read this line, Henry. And so in his nice little southern drawl, he goes, the rain in Spain falls mainly on the plains, or whatever it is that we sent him, right? And then we're just like, now read this, now read this, now read this. And we just feed it in to our model to generate a voice that is as close to Henry's voice as possible. And then what we did is we rigged up in 3D a model, and we started to model Henry's face. Now, I'll be honest, I'm redacting it kind of for privacy, but also this is from a really early prototype, so like, talk about uncanny valley, like, isn't it, I'm Henry, you know, like, it's not great. They're working on it. But we're putting him in a hangar, and we're allowing folks the ability to say, hey, so I forgot this maintenance procedure, right? Can you help me walk through that? Okay, well, all right, so the maintenance procedure is this, come over here, right? And he's showing you things, right? And this is all on a desktop right now. We're not doing it in XR, but eventually you can imagine wearing an XR headset where maybe it's not a 3D Henry, maybe it's just, you know, a made-up video call of Henry. Raise your hand if you've heard of a deep fake, if you've heard that term before, right? So imagine we are not only getting audio from Henry, we're getting video from Henry. Henry, cross your eyes. Henry, display teeth. You know, like, Henry, do things on the camera, and we're gonna record it, and we're gonna build a deep fake of you. So imagine you have an XR headset on, an augmented reality headset on, you get a video call from Henry. It ain't Henry. Spoiler alert, Henry doesn't exist. And you go, Henry, dude, I need help with this. And he goes, all right, well, let me just see what you're seeing real quick. And the headset uses, you know, things like laser beams, LiDAR, right, and camera vision, or CV, right, to determine the thing you're looking at, and it highlights it for you in 3D and says, okay, let's walk through this real quick. Okay, so open this up. All right, next step, find the blue wire, cut the blue wire, the bomb's disarmed, or whatever, right? So we are working on this, and I do not know too many other companies that are out there doing this right now, locally at least. There might be one or two other ones that are interested in the premise themselves. So the idea here of a metahuman is not too far off. And the idea of having not just a metahuman, but literally a deep fake of someone who is an expert explaining to you things. Okay, so there's a fantastic, y'all, you have to look this up. There's a fantastic content creator now who is using deep fakes of Taylor Swift, deep fakes of Dua Lipa, deep fakes of, I mean, you name it, right? Insert celebrity here. It's video and it's audio. And he's going, hey, Tay-Tay, can you tell me about geometric dimensioning and tolerancing? And then Tay-Tay's like, well, okay, yeah, that's a great question, so I'm gonna break it down for you. And students love it, because they're like, oh, hell yeah. Dua Lipa's teaching me about, you know, like nuclear particle physics. And it's a delight, right? And that's an example of a deep fake that has educational benefit. We're working toward the same thing. Let's talk about OpenAI and how they're kind of seeing the same thing too. What is this? What? OpenAI just bought something called Global Illumination? It's a what? It's a game company? Shut it. No, they make games. Why would OpenAI want to buy a game company? Why would they want to buy a game studio? Really interesting, right? What do they want to do with that? So just recently, when they bought this company, people were like, okay, that's kind of cool. Nobody really talked about it. What does the company make? It makes a Minecraft clone of all things. Minecraft? What? You're gonna go mine some resources? You gonna tell ChatGPT to go ahead and build like your Minecraft base? Like, They had something that they've made called biomes. And what biomes is is a sandbox environment where you can go and interact with AI created and interactive characters. You can go in on your own or with a community of folks that are real and find community immediately there, performing things, doing things, et cetera, right? Imagine a bunch of generative agents. So those are kind of helpful, action-based models that can generate the thing that you need to have done in a space, not just biomes, not just a video game, but in any kind of virtual space where, hey, I'm gonna do some digital engineering. Hey, raise your hand if you know the acronym MBSE, Model-Based System Engineering. All right, couple of y'all, because we're about to talk about it. It's gonna get weird. In digital engineering, the premise of engineering something is we do it digitally before we go bend the metal. We do it digitally before we go bend the metal. Because once you bend the metal is bent and it's screwed together and it's all, and I'm gonna talk about this in a minute, right? Imagine being in a generative AI environment with generative agents, asking them to help you build something visually in a headset and validate your assumptions before you go say, all right, now we're gonna send it to go get manufactured, cut up, et cetera, right? This is what OpenAI is looking for right now. And it doesn't have to be a digital engineering, it can be anything, any kind of task that they are interested in. All right, so what? Another buzzword I just kind of queued you up for? All right, I'm sorry, I apologize. We're not gonna talk about digital engineering too much more. Yes, we are. All right, so this is another product that i3 created. One of the things that we were very intrigued by was something called the GCS, or Ground Control Station, right? I think there's another variant called the Universal Ground Control Station. I'm supposed to say that. Apparently everybody's like, no, say the UGCS, say it. So no, it's been the GCS for as long as I live, so it's the GCS. And if you have ever seen a GCS, it's a big bulky machine with a bunch of screens and a keyboard and a trackball and it's got all these controls on it. And it was, I'll say this with as much niceness as I can, it was engineered by engineers and the experience was made by engineers, right? And some of y'all are like, yeah, okay. You know, no one was thinking about the user experience or UX of this product when it was made. And no one had an opportunity for as long as it's been around to validate assumptions about how you use it, right? So, prime example, there is a very important function on this ground control station that you have to do that includes getting your hand out to reach for the control key, and then you gotta stretch it up there to like the number 6, and then you gotta move your finger over to the shift key over here, and then you gotta take your other hand, and you've got to like go over to like this button over here and hold this, and then you've got to kind of stretch across to, you know, use this little toggle right here. And there's actually like 1 or 2 more key commands you have to do at the same time that you cannot do because you don't have enough hands. And I can't tell you the number of times I've heard people talk about their temptation to lick the keyboard or, you know, like use their nose, right, and get a crap ton of pimples. They have to ask their friend next to them, sitting next to them in the other GCS, hey, I gotta do this thing. I'm like, oh yeah, you gotta do the thing. And that person will reach over around them and hit the final, you know, command, right? It's a mess. No one thought about the user experience of this. But we didn't have the ability to kind of do that. If we were gonna bend metal, for example, to kind of get closer to it, it would have taken time, money, effort, right? That's all things that the government doesn't like to know about. They're just like, no, just get it done. Cost, schedule, performance, just cost. You know, maybe schedule's more important. You know, like there's not really a lot of conversation going around the user experience of these things. So we decided, well, what if, let's imagine the GCS was living on a computer. It thought it was a GCS. It's like, I do all the things that a GCS does. It thinks it's people, guys. It just thinks it's people, right? And we connected that to the ability to paint, basically, in XR. Right? Oh, I want to put a keyboard here. I don't like the keyboard. I want to put the keyboard here. I want this. I just want 1 screen. Now I want 5 screens. I want these switches to be here, 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 and here, right? And that is known as model-based system engineering. You're making a model of the system, and it thinks it's the system, right? I joke with all our MBSE engineers because there's a piece of software we have to use called Cameo. And it looks like it came out of Windows XP. It's like 20 years old looking, and you basically, when you look at it, it's just a bunch of boxes inside boxes. Like, I think that I'm a bundle of wires. But I know that inside of that box is all of the ohms and the voltages and et cetera, and the transistors. And inside of that, what is a transistor, right? And then you got to model out what a transistor is, right? And instead of that, like it's boxes inside of boxes, right? And we modeled out a good chunk of the GCS, and then we gave that to some engineers. See that dude right there? The dude's named Jake. Jake is not a 3D artist, as you can tell. He didn't have 3D generative tools at his beck and call just yet when we were working on this. And Jake said, okay, cool, I'll help you build out the application. We'll connect to the model over here. And now, when I put the keyboard in there and I do the things on the keyboard and I have the screen in front of me or the 7 screens or whatever it is, right, I can put them where I want. And in this XR headset, I can feel what it feels like. What's it feel like? I'm reaching way over here, I don't like that. Oh God, my arm, right? And he can determine the experience of the GCS and make judgment calls about the GCS before the GCS gets made. Now imagine that's a lunar lander. Imagine that's a car. Imagine that's, you keep going, right? That you can make a thing that thinks it's a thing, and then you can test out your assumptions about the thing before it becomes a thing. You know what I'm saying? Y'all know what I'm saying, right? Where does AI come in here? All right, another jargony term. Linear regression. All right, we're gonna talk a little bit about what linear regression is, but here's why. Now imagine the GCS thinks it's a GCS, right? But everybody knows in the real GCS, when you keep hitting that shift key, the shift key breaks again and again and again. But you've got anecdotal data about it, right? Now imagine that when you modeled the shift key, again, the ohms, like the transistors think they're transistors, right? You have to model what a transistor is and does. Imagine you model what a keyboard is and does. We're using this type of plastic. We're using this type of metal spring. We know we have to hit this key 1,001 times. Let's build something that reflects that. So linear regression is just a statistical model. It's really just kind of more of a statistical technique that helps you build a relationship between a solid variable, right? So something that's dependent. Imagine the key, right? Or a piece of equipment that you're constantly moving up and down, right? It thinks it's a thing. And one or more independent variables, like temperature, right? Like friction, like you name it, right? Like light and UV rays, right? Things that we can apply to this dependent variable. Hitting a key on a keyboard a bunch of times, the spring starts to break down. The plastic starts to scratch. The key becomes wobbly, right? If you do this linear regression modeling, you can do what's called predictive maintenance. Predictive maintenance. You'll kind of get where I'm going with this, right? You can predict what's going to break first. You can predict what's going to last longest, right? You can, with this model in XR, say, I'm going to drag this slider and I want to go ahead and say 10,000 keyboard strokes on just the shift key. And it will use that linear regression model to say, all right, everything I know that's going to be impacting that shift key 10,000 times. And then you go, oh wow, it didn't break, or it did break. Or we'll take it even further. If you needed to train on how to use that keyboard and you came across a GCS that's real old and you didn't know that keyboard was going to break, you need to be trained on how to replace that key when it breaks, right? You can build what's called a digital thread from start to finish into training. And this is one of the things that we're looking into at i3. So what does that mean? It means that if you have a model of something, an MBSE model, that thinks it's people, it thinks it's a keyboard, right? And you apply some linear regression modeling on that, hey, this keyboard gets hit this many times, and this heat and this friction and blah, 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 right? Then you should be able to build a nice little digital thread that says, because this key is going to be hit 10,000 times on the regular, we need to train people on how to replace the shift key. And you can, in the same XR headsets, tag that and say, that's going to be useful for training later, right? And then, in that same XR headset, instead of developing the thing, imagine somebody who's about to use a GCS puts that headset on, it's in maintenance mode, right, or training mode, right, and you go and train on how to replace the key because you can just have an instructor say, hey, now I'm going to show you what happens after that key's been hit 10,000 times. Go learn how to replace it, right? And that's a full life cycle in engineering. It's not, we made the thing and then we discovered the things that happened with it later. Now I got to train people up on how to replace this panel or, fix the screw that keeps falling out, right? It's, let's train them up on the things we know are going to happen because we've made it digitally. And we can do all of that so much quicker than waiting for the breakdown of the equipment to happen, right? That's a materials science problem. And government ain't got time for that. I mean, they do, but we want to save them money so that we can do even cooler things together. All right. So let's talk about the interface portion of this, right? I got a little jargony. I apologize. Thank you for forgiving me. Thank you for being gracious. I want to talk about a jargony word called user experience or UX. Raise your hand if you have heard the term UX or user experience. Heck yeah. All right, so my background is in a lot of things, one of which is user experience. Working in software land, when you make something for a commercial customer, for example, you don't want them to get frustrated and go, I don't like it, right? Have you ever downloaded an app that sucks to use, right? There's also kind of gradients in the age here too. Like I'm older, like I'm in my 40s and I'm like, I don't like that app. I don't like it, Meanwhile, you're like, yeah, cool, Snapchat, it's whatever, right? And the ways that we use the apps are different. They can change, right? It's all based around me as a user, you as a user, and how we experience that application, right? For good or for bad. And there are whole teams, fleets of teams that are constantly getting this feedback from the applications that you use on your phone or on your computer, right? They're bringing in folks to try things out in person, and they're not even saying, do you like it or not? They're like watching them, they're observing. And they're going, oh, it looks like it took them a long time to get from point A to point B. That's really important to know. We gotta reduce that time. We gotta reduce the number of clicks. We gotta reduce the blah, 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 right? And they're constantly thinking about this. So we're gonna talk a little bit about user experience because the user experience we have with our phones, with our desktop computers, they're not the same as an XR headset. I'll get into that for a bit. All right, take a look at that. What are those? They're windows. It's a window. What's a window? Can someone kind of take a crack at what a window is? It's a window. Yeah. Yeah. What? Did you say propaganda? Oh, Mac propaganda. That was a good joke. What's a window? Well, let's talk about what a window is for, right? This is where it's kind of weird, right? We're literally talking about interface design right now. A window lets us look into a task. It gives us a perspective on a task, right? It represents a nice square thing for you to say, this is where these kinds of tasks happen. Microsoft Word, inside the window, I put text in it, right? Snapchat, I hit this button to press the camera button and take a selfie and respond back to a message, right? When I don't want to use Snapchat, I activate on my phone the ability to multitask and see kind of like windows. They're cards. They're metaphors. They represent the thing that you're doing, right? And that is easy for us as human beings because we know what a window is in real world, right? When I say a window, it's like that thing over there, right? There's not a lot of windows in here, right? We know what a window is. When you look into a window, you see the thing on the other side and you go right on, right? Menus. Everybody knows what a menu is in software. You've heard that term, right? But what's a menu in the real world? I want some spaghetti with a meatball, and I want a Dr. Pepper, and I want it, and I also want a side of green beans. I know I don't normally eat green beans with spaghetti, but your green beans are so good, and it's on the menu, right? We're looking at a list of options, and we're selecting from that list of options something that we want. That's in the real world too. And we intuit that when we look at a menu on an application too, in a desktop. We know what that is, right? Forms. You had to go to the DMV and fill it out to get your driver's license, right? Some of y'all had to do it with paper. Some of y'all do it now on a computer screen. And it's the same. You have a space that's a text field, and you input the thing in the text field, and you go to the next text field, tab, or a touch screen, touch, So many services out there that can auto-populate stuff because we don't even want to fill out forms anymore. Buttons, man, I don't know what button is. I've been hitting buttons on this thing this whole presentation, right, to go back and forth. There are buttons in applications. The button you use to take the camera shot with your Snapchat, right? There is a button that we all recognize in the real world when we intuit what it would mean to see and use a button on an application, right? This is an interface. This is what people have determined for decades and decades with the apps that you use on your phone and on your desktop, what the real world equivalent might be for you to kind of get how to do it, right? All right. So if a window or something along those lines is a metaphor for a task, right? Every time you look at a window, you know that it represents a user experience for folks. We know to drag a window. We know to swipe up on a car. We know to hit a tab, right? We know how to do that now. It's been around for decades. It's like burned into our brains since we're young, right? And because of that, there is something called an information architecture around this that we intuit too, right? I know that at the top of the window is going to be a title bar, and the inside of the window is going to have the thing, and sometimes there's a sidebar. I know the sidebar helps me navigate things that are bigger than what I'm working on in the middle part, right? So look at these windows up here, right? You go to one of these text-based LLMs like ChatGPT, and what do you see? You see a form field at the bottom. And what do you do? I got to click on the form field, right? And then you see the cursor blink, pop, 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 pop. And you're like, I'm going to type the thing in now because I know that's what you do with form fields. Help me make a cat. Tell me about cats, you know, like, and you're typing. You're already going. You're already telling that story, right? You know how to do that. It's natural. And then what's that sidebar right there? Oh man, those are like where the big things that on ChatGPT I was doing, I can click on it and I can see the whole results of the center thing right here in the middle of the window, right? And this whole window is the task. It's a metaphor for the task, right? So I'm gonna get a little jargony here. Windows have an understood information architecture because we're just used to them at this point, right? And what does an information architecture do? It helps you classify patterns for the way you're gonna use it, right? Okay, so I know sidebar is always like this, so I'm gonna use the sidebar the way you use the sidebar, right? I know that a button's always gonna be a button, et cetera, right? You can classify it in your brain. Because it's classified, it's gonna communicate what you're afforded to do. I know that buttons let me do this, so that's an affordance, right? It's a UX term. And it's gonna craft context for input and output, right? I know that when I hit this button right here, it's gonna do this thing in the window and et cetera, I know that it always is gonna do that, right? All within a well-known information architecture. All right, a little jargony, but suffice it to say, we all agree, when you see a window, we know it's a metaphor for a task. When you see an app on a card or on your phone, you're swiping it away, you're going to a tab. This is just stuff we know. It's just burned into us now, right? XR is not. Oh, Lordy. This stuff's weird and spooky. Makes me uncomfortable. And I work with it every day. And you know why that is? Because XR headsets are attempting to represent the real world to us. If a window is a metaphor for a task, spatial experience is the task itself. It's the task itself. When I drop this thing in the real world, there's not a window around it that goes, hey, this window represents picking up things. Oh, good, I'm glad I knew. Awesome, wouldn't have known, right? No, we drop it, we pick it back up. That's the real world itself, right? And that's why there aren't a lot of metaphors for doing things in XR. You don't see a lot of menus in XR. If you do, they're really kind of helpful for you for some things that aren't necessarily a part of the real world that's being represented, right? So if I drop this thing in XR, I'm gonna lean down to pick it up. Or I accidentally dropped it. I don't want to pick it up. So I'm going to activate the menu on my wrist and go, hey, can you reset that in my hand, right? I don't have time for that. My legs hurt. I'm in my 40s. So the idea here is that the objects in the real world that I interact with being represented spatially on an XR headset, there's a little something, something. If y'all are interested in this, if this is piquing anybody's interest, there's a book out here, came out a few years ago, UX for XR. Man, is that acronym soup. User experience for extended reality, right? And that came up with a concept called object-oriented user experience. How many of y'all have developed or coded? When I say the word object-oriented programming, y'all kind of know what that means, right, to a degree, right? So object-oriented user experience is a new term that's been coined and a framework around which you perform tasks in XR. And that really has to do with the way that you use XR then and how it's going to be now in the future. And all of the information architecture, it's not just understood, it's intuited. Because I know when I drop a thing, I'm going to go pick it up. I just intuit that. I've been doing it since I was little. I've been throwing crap when I was like 1. I don't remember that, but I mean, like, it burned itself into my brain, the neurons fired off and connected, and I realized, oh, I can throw things, right? And then I get in trouble, and I gotta go pick them up. Oh, now I can pick up things. I gotta pick up things. So all of those patterns that I talked about that you would classify in your brain with a window, the affordances, the things you can do with it, the context that are created with that, it's just what we would expect in our human brains, right? Won't hammer this in too hard, but to a degree, it's kind of like the real world. This is it. This is it, y'all. If you're wondering what the interface for AI would be if it were XR, it's absolutely the opposite of these LLMs right now. And just guess what? It's not just LLMs that we interact with, it's dashboards, right? It's not just dashboards, it's video. It's not just video, it's images and et cetera, right? Everything that we're used to seeing on a screen, those are contextualized heavily by what we think of in terms of interacting with software. Not here, baby. Nope, not the same. And because of that, all of the content that we can learn to create on things that that are known quantities, Windows and game engines and blah, 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 right? Even going so far as to doing things like digital engineering inside an XR headset. Not just the content we can create, but the things we can make in XR and use AI with, right? That's it. That's it. We are bridging the gap between the experiences of real life and AI. We're getting closer and closer and closer and closer and closer. That Twitter video I showed you, weeks old, maybe a week old, right? To be able to like spatially see something that you filmed with a camera and it makes sense of it in an XR headset. I'm gonna leave y'all with this video, right? So how many of y'all have heard of CES? Right, big, like there's, it's a big conference that you see like all the latest GPUs, like the graphics cards that come out, hardware, video games, you name it, right? At CES this year, just weeks ago, right? Happens in the time span of weeks, right? Siemens, big company, announced their partnership with Sony, big company, to make what they were calling immersive engineering. And the CEO on stage, Roland Busch, in his thick German accent, said, "We envision the industrial metaverse." I don't even know if he's German. I just copied this quote from the internet, but I'm going to say it in a German accent anyway. You can't stop me. I'm on stage. I got the microphone. "We envision an industrial metaverse as a virtual world that is nearly indistinguishable from reality, enabling people, along with AI, to collaborate in real time to address real-world challenges." My name is Roland Busch. And they released this video. Now remember I showed you that MBSE XR experience, right? Well, of course, a big company like Siemens and a big company like Sony did us up, but the concept is there. We did it locally first, you can't stop us. So everything that I talked about, creating in an immersive experience, using AI to help you generate content, let alone using AI in an environment, right? Imagine it's not just collaborating with humans, but generative agents, right? You can make stuff before you go make stuff. Now, a lot of students in the room, you have a good idea. Oh man, how do I get that good idea out of my head? Well, I'm not a 3D artist. Well, I'm a developer, but I'm only okay, right? Don't know UX very well, I'm not a designer, you know, all this stuff, right? Imagine being able to collaborate with your friends in an immersive experience, leveraging generative AI in some way, shape, or form to build something and sell the premise. You got a startup right there, right? Imagine you're at work and you have paid attention to this presentation enough to go, this is where it might be going. I can't guarantee that, don't like futurists, I'm not one, but it could be going here, subjective, right? Imagine being up to speed on this kind of stuff, thinking about it already. What does that mean for you? What does that mean for the places you're going to work at, right? Oh, I can solve this problem. Well, how do you solve it? You're not an engineer. Well, I don't have to be an engineer, right? I have a good idea. Let me go take this next step. Oh, I can solve this. Well, you're not a 3D artist. You can't visualize it. I don't have to be, right? Et cetera, so on and so forth, right? You can collaborate with people. You can collaborate with AI. You can generate content that would go into the application. You can make an experience for someone to get the idea, and boom, you're off to the races, right? So be thinking about this, because in the future, it's up to you what you think generative AI should be doing. It's up to you what you think XR should be doing, right? The experience that you give these companies feedback loops for, I love headsets, man, but they're really heavy. You know, like, okay, well, let's make, you know, less heavy headsets, less bulky headsets, right? Man, I really love generative AI, but I hate typing. Okay, cool, let's make it audio-based. Or let's have generative agents that you say, can you help me describe this thing and fix it for me? Oh, well, I'm a generative agent that's really good at this or that, right? So on and so forth. So, with that, you hold the keys to the future. Don't call yourself a futurist, it's a terrible term. But thank you for coming and thinking about it with me today. All right, so let's ask questions. I will do my best to answer them. If I don't know, I will say I don't know. Pragmatic at heart. What y'all got? What are you thinking about?
One thing that seems to be left out of XR is smell. Do you foresee that being incorporated in the future? Well, I guess you're not a futurist, but
yeah.
What do you think of that?
That's a great question. So since the 90s, we've been trying to figure out smell. That's a lot of material science and chemistry that is not easy to do, at least repeatedly. And part of the reason is you've got to have very particular elements mashed together to make a fragrance, right? There are instances though, and I've come across some equipment that is designed to, for example, make something smell like smoke or as though it's on fire, right? Because your brain is going to register a fire, for example, much quicker than your eyes, than your ears, than your senses, right? Like even if you're, let's say you're in an aircraft and something is on fire and you cannot tell because it's hot, it's stuffy, you know, you've got a headset on as you're flying, whatever it is, there have been tools out there designed to do that. The big challenge with it is they are proprietary, very proprietary. You can't go to your local hardware store, you can't go to Ace Hardware and be like, I'd like to buy all the chemicals to make the smell of an orange, you know? It's not super easy. So to that point, there's been a lot of attempts for other senses. So there's something called haptics, haptic feedback, right? There are gloves out there now that have little sensors on them that will, for example, vibrate and give you the sense when you touch something that you can feel it, right? There are gloves out there that have tensioned like lines in them. So when you reach to grab something, if you are getting close to virtually wrapping your hand around it, it will stop your fingers and give you the sense that you are touching it, right? Audio, obviously something we can do right now. Touch, getting there. Smell, very particular, you know, instances. I think, I'm not a futurist here, that if there were an application that smell was imperative for, right? Like let's say you're teaching cooking in XR. I mean, you could visualize that the eggs are burning. What are you gonna do? What happens when eggs burn? You're like, oh no. Oh lordy, no. You know, like you smell it first, right? So there could be applications where that is the case, but it's very chemistry heavy and you have to replace the assets that produce the smell again and again and again, unfortunately. So, yeah.
So it's the chemistry that's holding it back.
Yeah, if anybody wants to be a chemist, go ahead and hit that up. Just start it, yeah. What else?
I have one over here. I know this was a few years ago, and I was just curious if any of the newer techniques were brought to it as well. After the fire in 2019 in Notre Dame Cathedral, I know they took a lot of the video that they put together for Assassin's Creed Unity in order to reconstruct it. Do you know if they're using any of these new things? Because it's due to open, I think, at the end of this year at some point. Do you know, since the present kind of stuff, but it seems like this would make sense for sort of the finishes and things like that at the end.
Yes, there are virtual museums out there that are designed to be viewed in a headset. They are captured using, 360D cameras. So there's a file format called 3D 360. Not a universal scene description, but 3D60, and there's another format called VR 180, and these use camera lenses to capture, obviously, the degrees, right? I want 180 degrees of freedom. I want 360 degrees of freedom, right? And a lot of these cameras are also stereoscopic, meaning they can interpret depth, right? Like Gaussian splatting, like neuroradiance fields, but not the same, people have been using this technology now to give people experiences of museums without having to travel to the museum. So with that in mind, especially since like post Notre Dame, fire, there have been attempts at major places that are works of art, they're religious places like churches or temples, right? There are attempts to kind of go and capture that a little bit better. And the idea being that we can preserve that and experience it after the fact, right? Now, I don't think I've seen anybody use Gaussian splats or neuroradiance fields for a cathedral. I think what I've mostly seen it for is people showing off on LinkedIn that they were able to access the GitHub and deploy it and say, I made a thing in my backyard, right? Or I attached it to my car and it's really cool. So I haven't seen any professional examples just yet. Yeah.
Hello.
Hello.
Fantastic presentation. I'm going to guess this is a UX question. So there's a difference with like when you're writing an email off of your phone versus like writing off your laptop. Sometimes, depending on what generation you are, it's just faster typing. Mm-hmm. So then you move to like the current commercial headset out where it's eye tracking for UX and you're touching your fingers and whatnot, but how do you, I have several part questions, but one is the eye tracking, do you perceive like there's going to be a lot of fatigue with eyes, right? And in the last video with the Siemens and Sony, but they were kind of doing a hybrid with like the headset plus still like hand controller thing. So kind of not as the futurist, but what do you kind of see as a way for more mainstream folks using headsets? What do you think it might be? Because it's right now very open, as you were describing. It's not been defined, and sometimes it's easier. Like when I've had people not go through training on Vision Pro, they just want to do this, which is interesting, intuitively.
Yeah, that's a great question. So there are pieces of equipment, headsets, and lots of things out there that are attempting to bridge the gap, for example, for writing emails, right? So I'll start there. There was a fantastic product. It's super inexpensive. It's not like the highest grade hardware. That is literally, it is a keyboard with a tethered, it's got a cable to an augmented reality headset for you. And this is an attempt to replace the traditional laptop screen with something that can allow you to have spatial screens everywhere and view 3D and et cetera, right? I've seen people in airports using this at this point, right? It's pretty commonplace. It's also very expensive, low barrier to entry. And what that does is it affords folks the opportunity to do the thing that they're used to doing, which is writing an email on a keyboard, right? Without feeling hindered or frustrated by the headset, right? There are attempts at that. There are also attempts, and I've seen this done really, really well, with XR headsets generating buttons and keyboards and things like that. And you had mentioned like they want to reach out, touch space, right? Like they want to do the thing. Yeah, it's propaganda. Yeah. We come across this often when it's a fully immersive headset and someone wants to go do what they would do in the real world, right? There's no metaphor for a task. The task is the thing. And so, Siemens has controllers. But controllers are things that you can learn and get comfortable with compared to making assumptions in a headset that things will react like they would in the real world. If I'm going to go reach out and grab that, steering wheel controller that they were putting in the race car, right? Like I would want to grab it, right? And yet, exactly, I got a pinch, right? The reason that we do this on headsets is because the headset has sensors on the front of it and cameras, and it goes, I recognize a gesture. That's AI right there. It's recognizing the gesture, right? But if you do it like this and the camera is facing away from you, right, it can't see it. And so if that's what you would do in the real world, if I were to pick something up and do this, it couldn't see it, right? And there are technologies out there that are attempting to abate that challenge and make it even more like the real world. So there are physics-based skeleton rigging plugins for Unity that will map to your hand and then make assumptions no matter where your hand is spatially, positioned in space, around what you're doing, right? With using sensors on almost every contemporary headset. Meaning that the person that reaches out in Vision Pro to do the thing, right, there are things out now that let you do that, right? We've got tools that are bridging the gap like Siemens. We're going to give you some controllers that still feel a little bit comfortable because you'll learn that this controller is used for this kind of thing and that controller is used for that kind of thing, right? The Ring. We're going to see hardware out in the real world right now where they're bridging the gap with a keyboard. Hey, we're not going to make you do a virtual keyboard. That's dumb, right? But I'm the same way. I don't like typing emails on my phone. I hate it, And email is still a primary function around working, and emails have a heavier sociocultural weight when you send an email to leadership than you do a Teams message, than you do talking in person, than you do whatever, right? And so that's still going to be around. It's not going to disappear. And as we see hardware kind of, try and bridge that gap, or as we see software try and bridge that gap, I envision that we're not going to be too far off from it being truly spatial, or just like in the days. Everybody remember the BlackBerry? Yep. And when if you've seen the BlackBerry movie, right, that when the iPhone came out, they were like, oh, it doesn't have a keyboard. How are you going to do email? How are you going to do the emails? Yeah, right. So it's also changed the way that we write emails. When you get an email and it's sent from your iPhone or whatever, right? With your little kind of like mobile signature, it's not going to be a long email. And if someone did send like a paragraph of text, you're like, dear God, what were you doing? You just sit there for like 4 hours and bang this out, and scroll for typos? No. So literally the way that screens do this now have changed the way we write emails. There's the possibility, and again, not a futurist, that the way that we communicate with email in the future spatially may become different too. So.
Hi, my name is Gabriella Phillips, and I was wondering, we've been talking about a lot of the positives of VR, AI, and augmented reality. Mm-hmm. What would you say is some of the negatives that are currently in the field that the field is not addressing or is not putting enough effort to address? So, and follow-up question, okay. What is some technologies that could be helpful in the field that the field is not utilizing?
Great question, and it's very much tied to yours, right? Is the eye ever tired of seeing? No, but on a headset it is. There are academic, and I pointed out the 300 plus academic papers, research papers that went into finding the connection between AI and XR. There are even more academic papers out there of just fatigue of wearing a headset. It's exhausting. Who here has actually put an XR headset of some kind on their head? All right. Who here does things like VR chat and actually spends extended periods of time in XR? Don't be ashamed, it's all right. Who here has seen of that crowd videos of people who will go days without taking their headset off? Oh, heck yeah. Isn't it weird? Super weird. There are people who, and this is going to be a kind of a shock to some folks in the audience, I mean, this is a bulky headset too, it's heavy. It's, oh God, you know, like throw your neck out, right? Wu-Tang Clan reference. The headset is on all day long, and they have mapped out in the virtual environment that they are hanging out with their buds in where their bed is. So they will sleep with the headset on. They will map out where their table is and eat with the headset on. What are they eating? Polygons. But not really, it's like cornflakes or something, right? They just know where it is, right? They will, I think I remember seeing a video where someone went and talked to a therapist in XR, and they were kind of running, they were like, okay, it's week 2, haven't taken it off, been using the bathroom, shower, you name it, right? Haven't taken it off. And they're asking them questions. Tell me about how you feel. Tell me about your fatigue. Tell me about your mental fatigue. Tell me about your whatever, right? XR headsets are getting tinier. They're getting lighter. They're getting easier to wear. The Apple Vision Pro is an example of something that is even more ergonomic than some of the contemporary headsets. I believe that headsets are shrinking because the compute resources necessary to have a less bulky headset might go on a thing that's cooking your leg, right? And use something wirelessly, right? If you've ever used a Magic Leap headset, it's much lighter than a HoloLens. And they've got this little puck that's just tethered, right? And you just slide it in your pocket because the compute resources are too hot for the side of your head. And the headset is very heavy, right? I think the industry can learn some lessons from products that people, users, have complained about or said they like. And again, like I mentioned, if you have something that you're thinking about, you are the feedback loop for the industry, not me. Just a guy up here with a presentation. Eye fatigue in particular is one thing that has also been referenced. So you know that video I showed where it said 90 hertz the whole time, right? I mean, that was a performance, inquiry that the guy was making. How quickly is it rendering the thing that I sent to it, to my headset? And if you've ever used an old Sony VR headset, that's, it's pukey Suzuki. It's like hopping in an old Suzuki car and you're like, boom, boom, like no suspension, right? Like, because it doesn't match up with your eyes. And what ended up happening is people were literally vomiting in VR and going, I don't want to buy that product, makes me feel uncomfortable. It changed, and we got better and better at that kind of thing. One thing that I would kind of point out, not just for the headsets, but the experiences that you have in general that the industry could learn from, is if you go online and you're like, show me what's cool in VR. And like somebody's got a headset on and it's just like, God, I'll point it out. Starburst, the company Starburst, they made something called the Juicyverse. Dun. Stupid name, the Juicyverse. And in the Juicyverse, when you walk in, it is, I'm sorry, the Juicyverse. It's these huge buttresses and banners and massive buildings, and it's empty. It's not Notre Dame. I do want to burn those spaces. I'm going to burn the Juicyverse down, though. I'm going to go drop a candle accidentally in VR and watch it go aflame into great conflagration and great satisfaction in my heart. People are making spaces like that because they think they're impressive. And they're not, because this is not a huge space. It's a big space, but I feel intimate. I feel like we're having a good conversation. We're talking about stuff, right? But that eye fatigue, there are academic papers that justify that the depth and height and distance of things are fatiguing themselves mentally. And your eyes are trying to adjust to something that's huge and out there, and it's not great. And the most expansive, mind-blowing experiences I've had are small and intimate and confined, right? Right? Because I can see the details. I feel like I've got 4 walls around me, right? I want to take my headset off and give it to someone else because I experienced something that was meaningful and impactful, not a flying buttress with a bunch of Starburst glued to the top of it. This is Juicyverse and neon letters. So does that answer your question? Okay.
I've got a mic back here. When you were talking about helpful Henry, you gave the example of cut the blue wire to defuse the bomb.
Yes.
Is there any benefit of keeping the user in those situations when you could just throw that model into a robot and remove the user from a dangerous experience?
This is where I'm going to be a little bit futurist.
You said you wouldn't do that.
I know. I also said I wouldn't use jargon too, and buzzwords. I am a firm believer from a user experience standpoint that AI is a tool and will always be a tool. The idea of AGI, or like kind of this more sentient experience that you would be able to send a robot in and say, hey, go do the thing, and it does the thing, right? The relationship you have to that technology is from human to tool, human to tech, right? And if you were to send just a robot in to do that, what's it gonna do? Well, it's gotta report back to human beings, right? Or to some other system that says, I have defused the bomb, right? That could save lives. But, and this is just gonna be the kind of like sad late stage capitalism here in play, robots are expensive to make. They're expensive to make, they're expensive to maintain. They are functionally dedicated to only a few tasks. We see Boston Dynamics trying to make robotics that are doing lots of different things that are more humanoid in nature, but those are expensive. And if you watch the behind the scene videos of those parkour robots doing flips and you're like, ah, crap, I'm dead. I might have a ninja robot chop off my head, right? Those are the kinds of things that may go and defuse a bomb, or maybe something on treadmill, right? But you watch the behind the scene videos of those and the development of it, they're constantly stringing them up on hooks, removing panels, going, this burned out, that broke, this is not working right. And to perform that task to the degree that a human would be able to do, and again, you've heard people say it, like, this is powered by a light, like this is as much power as a light bulb, and still, right, we can go defuse the bomb ourselves. And we're paying attention to things, and there's nuances, and there's like a guttural kind of cluster of nerves that's going, oh, maybe it's not the blue wire, right? Like there's a lot that goes into diffusing that, and experience, tacit and implicit knowledge, right, I talked about in the 3D artists, that I believe are gonna be hard for a robot to go do. So I think we're still gonna have that human relationship with them, but I don't think we're gonna be able to necessarily autonomously employ robots like that for a long time. I think it's going to be a long time before we get there. But it's a very interesting premise, right, to save a life. Does that answer your question?
Yes, thank you.
Okay.
Hello, my name is Justin Wright, and kind of feeding into your, not necessarily futurism, but you mentioned...
Back for this all day.
Excuse me. You mentioned people possibly being able to, instead of like going into super specialized fields and learning how do I model this and that they could possibly just generate it. What implications do you think that has for not just like education or, actually yes, education.
Yeah. Education, like, art, skills, trades, learning, right?
All those things, yes.
Yeah, great question. So I was on a panel earlier last year. There's an event in Huntsville called Design Week Huntsville, and we talked about that very thing, right? How do artists and content creators use AI? Is it cheating? Like there's a content creator, there's a dude who reviews stuff at Huntsville, beefy boy YouTube channel. It's monetized, he's making lots of money. He's been using ChatGPT to help him generate scripts. And he's been feeding in, hey, this content creator does this kind of thing. Can you help me make some new ways I would make this video apparent to me based on these content creators, right? He's using it like a tool. Now, if he were generating the content to review the thing, that's gonna be a challenge for us to connect with it because we're not seeing the video that he made, we're seeing the video that was generated based on his conditions and standards and everything else that he put into a prompt, right? And the way that we relate to that is very different. When it comes to education, both on the learning side, the person learning something from a Helpful Henry, or the Helpful Henry himself, right, teaching the thing, it's all about, to the point of bomb diffusing robot guy back here, what do we relate to when it comes to that experience? What are we relating to? Are we relating to what we perceive to be a tool? Are we relating to what we perceive to be something that helps us learn something? Are we relating it to it on a more human level, where I actually enjoy hanging out with Helpful Henry? He's pretty helpful, right? And I feel that connection to Helpful Henry, even though on the back of my brain I know it's not a Henry, right? And it goes even further because if we have Helpful Henry modeled, his voice is modeled off of, or a deep fake of the real Henry, imagine the people who know him and how they'll respond to that, right? There's questions about how you learn, and we have a lot to do with this. We have a role where I work called an ISD, an Instructional Systems Designer. Their job is to design instructional systems. And those instructional systems are based on the tools that are available to them to teach the thing the best way, right? Man, the sidebar is great for navigating, but Nathan, I'm telling you, the UX of it sucks, and I need you to do this, and blah, 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 right? Now, let's say they didn't have to go to me. They were like, hey, the sidebar sucks. Hey, AI, can you make it better? Well, what are people saying? Well, okay, they're saying this, right? Okay, well, 89% of users that use sidebars typically are good with them, so we're not gonna, you know what I mean? Like, how you relate to something that can generate something that teaches you, or vice versa, that you are, kind of relating to something that is teaching you. It's a really murky space to live in, because ultimately, at the end of the day, all the tools that exist for us out in the real world, they're just metaphors for how we relate to people, right? It's really ultimately it. And there's a very human component to this that I could go wax poetic on and love to talk more about if you're interested in. But especially from an educational standpoint, the ways that we learn are always reflected back on the people that need to know how we learned it. Are we doing it right or not, right? So, does that answer your question? Maybe? Yeah, come talk to me after this. Yeah, we'll hash it out if you want. All right. Hey, I think we're done. Thank you all so much. If you have any questions, come find me. Let's talk more. If I didn't answer your question well, let's talk more too.
All right, thank you, Nathan, so much.